In this video, we're going to look at the differentiation rules. In previous videos, we used the definition of a derivative to determine the derivative of a function. Now we're going to use the rules which are derived from the definition of a derivative. We just don't have to go through all the algebra necessary to find the derivative. This is going to be especially important when we're looking at the higher order derivatives. We look at the constant of a multiple, and power rules for differentiation. We're going to do the sum and difference to combine derivatives. We're going to use the product and the quotient rule. We're going to extend the power rule to negative exponents, and we're going to combine all those rules to find the derivative of a polynomial or a rational function. This section allows us to bypass the definition of derivative. We're going to look at our first derivative rule, which is the constant rule. Now it says if we have this function f of x is equal to c, then its derivative is equal to 0. Now we'll see it maybe noted this way or this, where it's the derivative of c with respect to our variable, which in this case happens to be x, and is equal to 0. This makes total sense. A constant is a horizontal line. The slope of a horizontal line is 0. And since derivatives represent, one of the ways to interpret a derivative is the representation of the slope of the tangent line. Makes total sense. The next one we're going to learn is the power rule. And we talked a little bit about this in class this week. We did a little bit. We started talking about the connections when we were doing derivatives using the definition, and we were looking at polynomials. It says if we have some function is equal to x raised to the n, and we call this a power function, then f prime of x will be equal to this exponent of n will come down out front as a multiplier, and then x will be raised to 1 power less. So if we had, as an example, say we had f of x is equal to x to the third, and we talked about this in class. We did some graphing of these. We graphed the original function, which was a cubic function. We talked about the derivative and then the second derivative, and then we looked at it using the definition of derivatives. Using this definition of the power rule, f prime of x is going to be that power of 3 is going to come down out front as a multiplier, and then it's going to be x to the 3 minus 1, and so it's going to be 3x squared. So f prime of x is going to be the original power as a multiplier, and then x raised to the power minus 1. Alternately, we can express it as the derivative of x to the n with respect to x being our variable, is equal to n x raised to the n minus 1. So we know from section 3.2 the derivative of x squared and f is equal to f prime of x, which is 2x. And we talked a little bit about the graphing in 3.2. And we said, look, remember where there's a turning point here, that our derivative graph is going to cross the x-axis. The slopes of the original graph all the way up to this particular turning point are negative, so all of these slopes, or all of the derivative graph, is below the x-axis. These are negative outputs. Once we hit this turning point, we turn and all of our slopes are positive, and therefore the graph of the derivative, which is this blue line, is above the x-axis. Now we're going to start adding on to these rules, and the next rule says, hey, look, if I add two functions together, I can take the derivative of each one individually, just like when we're doing our limit laws. So then if I of x is equal to the sum of these two functions, then I prime is going to be equal to the derivative of the first function plus the derivative of the second function. So that's just like when we did our limit laws. Now similarly, the difference, if we have a subtraction, if we're taking the derivative of the functions f of x minus g of x with respect to x, I can do the derivative of the first function and then subtract off the derivative of the second function. And again, if we let j of x equal the difference of these two functions, f of x and g of x, then j prime of x is equal to the derivative of the first function minus the derivative of the second function. Now we can shake this up and we can add a constant to it. Now, the constant is just a multiplier, so we can bring that constant out front of the function. And then we can take the derivative of that function. So suppose we say j of x is equal to some constant times f of x, then j prime of x is going to be k the constant multiplied by the derivative of the function. So let's find the derivatives of these functions using the power rules. My first function is f of x is equal to 3x. I'm going to use the constant and the power function rules. So f prime of x is equal to 3 multiplied by, this is x raised to the 1. 3 multiplied by 1 multiplied by x raised to the 1 minus 1. So I'm using the power rule, and then the constant is just a multiplier. My final answer is 3 multiplied by 1 multiplied by x raised to the 0. Well, x raised to the 0 is just 1, so my answer is just 3. And that makes total sense because this is just a line through the origin whose slope is 3. So it would make sense that the tangent of this line will have a slope of 3. And again, with b. So let's go ahead and do b. Now I'm going to do a little bit more so you can see that I'm going to write this as f prime of x is going to be equal to. Now I'm going to use some notations that are slightly different. So I'm going to do d dx of 5x. Then I'm going to use the difference, minus d dx of the constant 3. So we know using the constant and the power rule, this is going to be 5 multiplied by 1 multiplied by x raised to the 0, because remember that was the power of 1 minus 1. Minus, and then we know the derivative of constant is 0. And our final answer is 5. But again, we kind of knew that because this is just a line, the tangent of the line, in this case, the derivative of the slope, so that can be interpreted as the tangent of the slope of the tangent line, is 5. That has to be the same. Now on C here, we know that C is different. With C, this isn't a line. And in fact, I'm going to write this as 1/7 square root of x, which is the same thing as 1/7 x raised to the 1/2. Now I can see the 1/7 is just a multiplier. So when I'm ready to do g prime, this is going to be 1/7. The exponent on x raised to the 1/2 is 1/2. X raised to the, and then I'm going to subtract 1 from there. So if I have 1/2 minus 1, this is the same thing as 1/2 minus 2 over 2, which is equal to a negative 1/2. So it's going to be x raised to the negative 1/2. So this is 1 over 14 x raised to the negative 1/2. Now if I don't like negative exponents, then I can bring x raised to the negative 1/2 down into the denominator, and I can write this as 1 over 14 the square root of x. And that is my final answer. Now, let me move all of this up out of the way. Let's take a look at h and e. The difference between h and e is that h is a polynomial. All of my powers are integers. These are not integers. And in fact, on e, I'm going to write this as x raised to the 1/3 plus 1/2 x raised to the 1/2 plus x plus 7. I'm going to start you off, and I'd like you to try d and e on your own. So go ahead and pause this video, and I'm going to give you the answers after you've tried it on your own. So go ahead and pause it. Welcome back. Hopefully you have h prime of x is equal to 21x to the 6th plus 18x minus 5. Because the 7 and the 3 multiply, and I drop a power. The 2 and the 9 multiply, and I drop a power. The 5 and the 1 multiply, and I drop a power. And x raised to the 0 is 1. Similarly, f prime of x should be 1/3 x raised to the negative 2/3 plus 1/4 x raised to the negative 1/2 plus 1. Again, the 1/3 is going to come down out front as a multiplier. 1/3 minus 1, which is the same thing as 1/3 minus 3 over 3, is a negative 2/3. And then I have 1/2 multiplied by this 1/2, which is going to come down as a multiplier. And then if I have 1/2 minus 1/2, of course, it's going to be a negative 1/2, or 1/2 minus 1, excuse me. It's going to be a negative 1/2. And then x raised to the 0 is just 1. So how did you do? If you didn't get it quite right, that's okay. There's plenty of practice in the homework and there's plenty of practice in the book. It's okay. Just keep practicing and you'll get them. Now let's look at the next set of rules. And on the next set of rules, we're going to have the product rule. What the product rule says is, say I have two functions that are being multiplied together, then let me erase this, then the derivative of the function, if these two are being multiplied together, now this is slightly different than the limit laws, because the limit law says, hey, if I have two functions that are being multiplied together, then it's the limit of the first function multiplied by the limit of the second function. That's not true when we're doing the derivatives. So if I have two functions that are being multiplied together and I want to do the derivative, I have the derivative of the first function multiplied by the second, plus the derivative of the second function multiplied by the first. So if j of x is equal to f of x multiplied by g of x, then j prime of x is going to be f prime of x g of x plus g prime of x f of x. This means that the derivative of the product of these two functions is the derivative of the first function times the second plus the derivative of the second function times its first. You sometimes will see this noted as uv prime is equal to u prime v plus v prime u. That's used a lot specifically with the quotient rule as well. When we start looking at the quotient rule, they use a lot of the uv stuff. So here's the quotient rule. And it's a little more involved. If we were doing the limit laws, the limit law says if I was taking the limit of f of x over the limit of g of x, then it'd be the limit of the f of x divided by the limit of g of x. That's not true with the derivatives. So if I'm doing the derivative of f of x divided by g of x, it's going to be the derivative of the numerator function multiplied by the denominator function minus the derivative of the denominator function multiplied by the numerator function, all divided by the denominator function squared. So if j of x is equal to f of x divided by g of x, then j prime of x is going to be f prime of x multiplied by g of x minus g prime of x multiplied by f of x, all divided by g of x, the quantity squared. Now, if you see it in uv notation, if we have u over v prime, it's going to be u prime v minus v prime u over v squared. Now, when we get into the chain rule, this will make way more sense. It's like, oh, okay. And you're like, why aren't we learning the chain rule yet? Well, let's baby step. Let's learn some of these rules first before we start jumping into the chain rule. Now, the very last one that I'm going to look at is the extended power function, which says, hey, it doesn't matter what my power is on x. Then it could be negative, it could be positive. It is basically going to be whatever that integer is, or whatever that power is. It's going to multiply down out front, and then it's going to be x raised to that power minus 1, whatever that power is. You've seen it when it was 1/2 and 1/3. This is going to extend so we can say, hey, when we have x raised to the negative 3, how do we deal with that? Now, if we're asked to find the derivatives of these functions, I have a couple of options. My first option is I can do this by the power rule, or excuse me, I can do this by distributing first and then just doing the power rule. Or I can do it by the product rule. For this first one, I'm going to do it both ways. First, I'm going to just distribute through. So f of x, excuse me, I'm not going to do the derivative yet. I'm going to distribute through and I'm going to get 3x to the third plus 3x squared. Now, if I just use the power rule, then this is going to be 3 is going to multiply down out front, so I'm going to get 9, x raised to the 3 minus 1, which is 2, plus 3, and the 2 is going to multiply down out front, so I'm going to have 6, x raised to the 2 minus 1, which is just 1, and typically we don't write that. Now, it wasn't that much brain damage to do the multiplication first. So because it wasn't, I would probably have done that. Now, let's use this. Let's do the same thing, but let's do it with a product rule. I'm going to call this u, I'm going to call this v. And when I use the product rule, I usually go over to the side and I say if u is 3x, then u prime is 3. If v is equal to x squared plus x, then v prime is going to be 2x plus 1. So f prime of x is equal to u prime, which is 3, multiplied by v, which is x squared plus x, plus v prime, which is 2x plus 1, multiplied by u, which is 3x. When we get done, and we're going to multiply everything out, we're going to get 3x squared plus 3x plus, I'm going to multiply the 2x and the 3x, which gives me 6x squared, and then plus 3x. This is going to be combining up like terms, 9x squared plus 6x. Now we got the same answer. You can see that we got the same answer. One was just a little bit easier than the other. Let's take a look at b. Now b I'm going to approach in two ways. Again, I'm going to first do the quotient rule, and then I'll show you an easier way of doing it. So if I'm going to use the quotient rule, u is 5x minus 3, u prime is just 5. V is the denominator, which is 2x squared. V prime is going to give me 4x. So f prime of x is the derivative of the numerator, which is 5, multiplied by the denominator, which is 2x squared, minus the derivative of the denominator, which is 4x, multiplied by the numerator, which is 5x minus 3. And then in the denominator, it's going to be squared. So it's going to be 2x squared squared. Now let's go ahead and combine things up, combine up terms, distribute. So in the numerator, I'm going to get 10x squared minus, I'm going to distribute the 4x on that 5x, and I get 20x squared. Distributing the 4x and the negative 3 is a positive 12x. All over, I'm going to have 4x to the 4th. And I end up with, when I get totally done, I'm going to get a negative, actually I'm not going to be totally done. I'm going to combine up like terms, so I have a negative 10x squared plus 12x over 4x to the 4th. In the numerator, I can factor out a 2 and an x, so I'm going to factor out a 2x. This is going to leave me negative 5x plus 3, and then in the denominator, I'm going to have 4x to the 4th. You can see the 2 and the 4 will cancel. This x and one of these x's cancel. Now I've got the final answer, which is negative 5x plus 3 all over 2x cubed. Now that's my final answer. It took me a lot of algebra to get there. Now, if I look at this denominator, it is a single term. It has factors, but it's a single term. Because it's a single term, not true here, I can go ahead and put this 2x squared underneath the 5x and the 2x squared underneath the 3. So in other words, I can do this. I can write this as f of x is equal to 5x over 2x squared minus 3 over 2x squared. That means I can write this. These will cancel down, so I have 5 over 2 x raised to the negative 1. It's negative 1 because I end up with just an x in the denominator, but I'm going to write it as negative 1. The rule that allows me to do this is if I have a raised to the negative n, then this is 1 over a to the n. And because this cancellation gives me 1 over x, then I can write it as x raised to the negative 1. Now the second one, the second term I should say, is going to be 3 over 2x raised to the negative 2. Now I'm ready to do its derivative. So I'm going to multiply down out front. So I have 5 halves multiplied by a negative 1 multiplied by x raised to the negative 2. And I'm going to have a negative 3 multiplied by a negative 3 halves, negative 3 halves multiplied by a negative 2, and then it's going to be x raised to the negative 3. And you're like, but that doesn't match that? Give me a moment. This is going to give me negative 5 over 2x squared minus, I'm going to write this as, let me see, I'm going to write this as 3 over x cubed. And the common denominator is 2x squared, so I need to multiply this one by 2, this term by 2, and this term by x, and I end up with negative 5x minus 6 over, and that should be a positive, over 2x cubed. And you're like, wait a minute, that doesn't match. Well, that's because I made a mistake here. When I factored out a 2 on the 10 and the 12, that should have been not 3, but it should have been 6. So it's actually fortuitous that I did it the second way. So this should be a 6, and this should be a 6, and look, we have the same answer. Is one easier than the other? I don't know. That's really up for you to decide. I find that I'm not consistent. Sometimes I'll do it this way, especially if I'm not asked to simplify, right? If I'm not asked to simplify, I'm going to go right here and be done with it. This one, I may or may not do. It's really up to you. I'm not going to tell you how to do the derivative. I'll just say do the derivative. We're going to learn other rules on top of what we just did. So it's going to really take practice, and you're going to have to make those decisions about which one is the easiest one to use in the moment. Some of them, of course, won't be able to be used for every one of them, but some of them will be easier to do in the moment. Now, G, there's no way I could have done what I did with B, or f of x, because it is a single term here. I was able to put 2x squared underneath the 5x and the negative 3. I can't do that here, so I'm stuck with the quotient rule. So let's go ahead and note what u and v is. U is the numerator, 7x squared plus x. U prime is going to be 14x plus 1. V is going to be x to the third plus x raised to the 1/2. That means v prime is going to give me 3x squared plus 1/2 x raised to the negative 1/2. Okay, so I'm going to have g prime, which is going to be equal to u prime, which is 14x plus 1, multiplied by v, which is x cubed plus x to the 1/2, minus the derivative of the denominator, which is going to be 3x squared plus 1/2 x raised to the negative 1/2, multiplied by the numerator, which is going to be 7x squared plus x, all over the denominator squared, so x cubed plus x raised to the 1/2, the quantity squared. I'll leave that to you to go ahead and clean up algebraically. If you want us to go over it in class, I will do that as well. All right, so on this one, I'm just going to rewrite this and distribute this because I don't want to do the product rule here because it's an easy multiplication, it's an easy distribution, so I wouldn't bother with the product rule there. So I'm just going to rewrite this h of x as 3x raised to the negative 2 plus 45x to the third plus 9x squared. That means h prime of x, using the power rule, is going to give me negative 6x raised to the negative 3. Remember, I'm subtracting powers. Plus, and I'm going to have 45 times 9, which is 135 x squared plus 18x. Check my 135. I think that's right. If it's not, let me know. All right, so E. I'm probably going to distribute. So I'm going to write this as f of x is equal to x raised to the negative 1/3. Because it's in the denominator, it's a negative 1/3. 3 is the index, so it's x to the 1/3, but the denominator makes it negative. And then plus, I'm going to have x over 2 square root of x plus 7 over 2 the square root of x. I'm going to rewrite this a little bit more x raised to the negative 1/3 plus, right, this is the 1/2 x raised to. The numerator here has a power of 1. The denominator here has a power of 1/2. When I do its appropriate subtraction, I get x to the 1/2. And then plus 7/2 x raised to the negative 1/2. That means f prime of x is going to be equal to a negative 1/3 x raised to the, if I take negative 1/3 and I subtract off one more, which is 3/3, I'm going to get negative 4/3. Plus 1/2 multiplied by 1/2, which gives me 1/4. 1/4. X raised to the negative 1/2. And then I have plus, that will be a minus because I'm going to have a negative 1/2 times negative 7, which gives me negative 7/4. X raised to the negative 1/2 minus one more, which is 2/2, gives me x raised to the negative 3/2. And that's my final answer. Now, on these, they're asking me to find the slope of the curve when f of x is equal to 0. Now, what does that mean? If you remember about our graphing, we want to find the slope of the curve is equal to 0. That's a turning point. Now, we know when we have a turning point or a horizontal slide that is where the derivative is equal to 0. So when we see this, find all the values in which the slope of the curve of y is equal to f of x is equal to 0. What they're asking me to do is do f prime of x and set it equal to 0 and solve. Now, if you remember from your pre-calculus 1 class, we were able to find the maximum and minimum location if it was a quadratic, and it was the negative b over 2a kind of shenanigans. What happens if it wasn't quadratic? We said, just kind of graph it as best you can, right? If you weren't using a graphing utility. Now we can find the location, which means if we know where the x is, we can actually find that max or min or horizontal slide location output by doing the derivative. So first thing we're going to do is find the derivative. F prime of x is equal to 3x squared minus 27. So if I set this equal to 0, the first thing I'm going to do is divide by 3. And so I got x squared minus 9 is equal to 0. So when x is equal to 3 and negative 3, that is the location in which I have turning points. What does that mean for me? And that means that I can start the graphing process. I know where maximums and minimums are located. Do I know which one's a max or a min? Not without plugging it back into the original function at this moment. We'll learn other rules, but at this moment we'll say, oh, we know this is either a max or a min, and this is either a max or a min, or horizontal slide, because that's where the derivative is equal to 0. That's when the slope of the curve is equal to 0. Let's take a look at the next one. F prime of x is equal to 6x squared minus 6x minus 12. So we're going to set this equal to 0, and I'm going to divide by 6. So I'm going to have x squared minus x minus 2 is equal to 0. So I set it to 0, and I divide everything by 6. X minus 2, x plus 1 is equal to 0. That means x is 2 or negative 1. This is a turning point or a horizontal slide. It's a max or a min, and the same with a negative 1. I don't know which one is at this moment, but I will be able to find out at some point by either plugging it in or rules that we're going to learn later. Now let's take a look at the next one. You could absolutely do the product rule here. I might do the product rule. I don't think it's going to be that bad. Let's do the product rule. So if I'm going to do the product rule, u is going to be 2x plus 1. That means u prime is going to be 2. V is going to be 3x minus 1. That means v prime is going to be 3. That means f prime of x is going to be equal to u prime, which is 2, multiplied by v, 3x minus 1. And then plus v prime, which is 3, multiplied by u, which is 2x plus 1. I'm going to distribute and set this equal to 0, and so I'm going to have 6x minus 2 plus 6x plus 3 is equal to 0. So I'm going to have 12x plus 1 is equal to 0. That means x is equal to negative 1/2, or 1/12. Now, I happen to know that this is the location for the minima because if I multiply this out, this will be a quadratic and its leading coefficient is positive. That means it's going to have a shape that looks like this. And this turning point for x is at negative 112. For this next example, what they're asking us to do is find the equation of the tangent line at x is equal to a. What does that mean? Find the equation of the tangent line. Well, the first thing you're going to do is find the derivative, f prime of x, or y prime, or dy, dx, or however you want to note it. Then the second thing you're going to do is set the derivative equal to 0 to find, oh no, you don't even have to do that. Why was I doing that? Then all I have to do after I find the derivative is the second thing I'm going to do is f prime of a, and this will give me the slope of the tangent line at a. And the third and final thing I'm going to do is I'm going to use y is equal to m, x minus x1 plus y1, and you're like, well, what is x1 and y1? Well, what we found from number 2 is your slope. That's your slope. And then the x1, which I erased there, that's a. Well, how do we find y1? Well, that's f of a. So that's all you have to do. And you will be able to find the equation of your tangent line. So let's go ahead and do this. So y prime is equal to 3x squared minus 8x plus 2. So y prime evaluated at a is equal, or in this case, x is equal to 2. X is equal to 2. Is going to be 3 multiplied by 2 squared minus 8 multiplied by 2 plus 2. So I have 6, 4, 12, that's 12. 12 minus 16 plus 2, which gives me negative 2. Now, I have the slope, so I have the slope part. I have the x sub 1. This is the same thing as x sub 1. I have to find f of a, which is this function evaluated at a. So it's going to be 2 to the third minus 4 times 2 squared plus 2 times 2 minus 1, which is equal to negative 5. So my equation is y is equal to my slope of negative 2, x minus my a value, which in this case was 2, and then minus 5. Now I'm totally fine with that answer. You don't have to simplify it anymore. You can if you want to. If we take a look at b, we're going to do the same kind of thing. So we're going to do y prime first. Y prime is going to be 3 over 4 x squared minus 1. Oh, that's lovely. That's lovely because y prime evaluated at x is equal to 0 is just going to be negative 1. So that's our slope at x is equal to 0. So y evaluated at 0 happens to be 0. That's even better. So y is equal to our slope of negative 1, x minus 0 plus 0. Again, totally fine with that answer. Now, with c, I'm going to divide an x out. I'm going to factor an x out of each of the terms of the numerator. I'm going to factor an x out of each of the terms in the denominator, just because I like to work with smaller numbers and smaller derivatives. So f of x is going to be x squared minus 6x plus 8 divided by x minus 2. Now, remember how we talked about continuity? Well, let's talk about where I have an issue in its domain. Can I actually do this evaluation? And the answer is yes, because if I were to factor this out in the denominator, I'd have x multiplied by x minus 2. So at x is equal to 0, there's a hole. So I can do the derivative of the function, I can't evaluate it at 0. When x is equal to positive 2, because this factors into x minus 2. When x is equal to 0, I can't evaluate the derivative at 0 because there's a hole in the graph. I can't evaluate the derivative at 2 because at 2, There's where we have a vertical asymptote. So at x is equal to 1 is totally fine. Now, I can go ahead and do my evaluation now, or I can do the derivative. Let's just do the derivative. So f prime of x, it's going to be the derivative of the numerator, which is 2x minus 6, multiplied by my denominator, which is x minus 2, minus the derivative of the denominator, which is just 1, multiplied by the numerator, which is x squared minus 6x plus 8, all divided by my denominator squared, so x minus 2, the quantity squared. And if I do the evaluation at 1 of this derivative, I'm going to have 2 minus 6 multiplied by 1 minus 2 minus 1 squared minus 6 plus 8. And then the denominator, I'm going to have 1 minus 2, the quantity squared. My numerator gives me negative 4 multiplied by negative 1 minus, and then in the other parentheses, I have 1 minus 6, which is negative 5, plus 8 is 3, all over 1 minus 2 squared, which is 1. I know I should have just put this in my calculator, but here we are. So I have 4 minus 3, which is 1, so my slope evaluated at, the slope of the tangent at x is equal to 1 is 1. Okay, now I have my m, I have my x sub 1. I do need to still find y sub 1, which is going to be f evaluated at 1. In my numerator, I'm going to get 1 minus 6, which is negative 5, plus 8, which is 3. In the denominator, I'm going to get negative 1, so I have negative 3. My final answer is y is equal to my slope, which was 1, x minus 1 plus, or minus 3, And that is my final answer. Now let's take a look at the last one, which is fairly straightforward. It doesn't have to use the product rule or the quotient rule or any shenanigation like that. So let's go ahead and just do the derivative. Y prime is equal to 21x squared. Y prime evaluated at x is equal to 2 is going to be 21 multiplied by 2 squared. So I'm going to have 4 times 21, which gives me 84. When a is equal to 2, or x is equal to 2, so y evaluated at x is equal to 2 is going to be 7 multiplied by 2 cubed minus 6, which is 7 multiplied by 8. So that 56 minus 6 is 50. So my equation is y is equal to 84, pretty steep slope, x minus 2 plus 50. And that is that answer. On these examples, we want higher derivatives until either we get to 0 or until we stop, until it tells us to stop. So let's go ahead and start doing the derivatives. The first derivative of the function is going to be 3x squared minus 4x plus 3. Second derivative is the derivative of the first derivative, which is going to be 6x minus 4. And then the third derivative of x is just going to be 6. The fourth derivative, not asking for that, would be 0 because it's a derivative of a constant. F prime of x of the next function is going to be 3 times 6, which is 18, x raised to the 5th, plus 14x. F double prime, so the derivative of that, is going to be 18 times 5, which is 90, x 90, x to the 4th, plus 14. F triple prime, the third derivative, would be 90 times 4, which is 360x cubed. Now, I can continue to take derivatives of this one, even though it's not asking me to do so. For the next one, I need to do 3 derivatives. So I have f prime of x is going to be 70x to the 6th minus this 2 is going to multiply by this 1/2, so it's just going to be minus x. E to the 2 is a constant, so that's as good as that gets. The second derivative of this is going to be 6 times 70, which is 420 x to the fifth minus 1. And then its third derivative is going to be 420 multiplied by 5. So 420 multiplied by 5, I put that in my calculator, and I get 2,100 x to the fourth. Now you know my trickiness. I have this overwhelming need when the denominator is a single term to distribute under each one of the terms in the numerator. I just have this need to do that so I can avoid the quotient rule. So this is going to be w raised to the 2, because I would put this w underneath here and then the w underneath there, minus w. So let me do that again. This would be w cubed over w, which gives me w squared over w, which gives me w. Okay, now I'm ready to do my derivatives. F prime of x is going to be 2w minus 1. F double prime of x is going to be 2. F triple prime of x is going to be 0. Way easier than the quotient rule. Okay, last bit, I think this is the last of it. It is page 8. So this is a long section. There's a lot going on in here. I would recommend some flashcards to write all this stuff down, but you do whatever you need to do. They're asking me to find the equation of the tangent line passing through the point. Ooh, that's nice. They give me the point. They want the equation of the tangent line. So they're giving me x1 and they're giving me y1. So all we need to do is find the derivative of this function. And then after we find the derivative of that function, evaluate it and then put it in the correct equation of a line. So let's go ahead and do the derivative. F prime of x is going to be equal to, well, the numerator is 6, and the derivative of 6 is 0 multiplied by the denominator, minus the derivative of the denominator is 1 multiplied by the numerator, which is 6, all over the denominator squared. So in other words, I get negative 6 over x minus 1, the quantity squared. So then f prime evaluated at 3 is going to be negative 6 over 3 minus 1, the quantity squared, which is negative 6 over 3 minus 1 is 2 squared is 4, which gives me negative 3 over 2. So what they want is y is equal to negative 3 over 2, x minus 3, that's my x1, plus my y1, which is also 3. That allowed me to bypass that last step of finding y1, so that's kind of nice. Okay, so find a quadratic polynomial such that f of 1 is 5. So this is telling me it has to go through the ordered pair 1, 5. They're telling me f prime of 1 is equal to 3. They're telling me the derivative evaluated at 1 is a positive slope. Okay. The next thing they're telling me is that the second derivative at 1 is negative 6. Now, we haven't talked about what the negative 6 represents. Now, f double prime evaluated at 1 is telling me that that is the, which we're going to learn, is the inflection point. And you're like, what? We'll learn about that. We haven't learned it now, so how do we do that? Well, let's think about what a quadratic looks like. So we know a quadratic is ax squared plus bx plus c. Now, we know this is our function, that's a quadratic. We also know that when we put in f of 1, that ax squared plus bx plus c has to equal 5. The first derivative of this function would be, I don't know why I've got the squared on the a. I would have 2x plus b has to equal 3. if I evaluated this at 1. Now, the second derivative, f double prime of x, would be just 2a. Now, 2a has to equal negative 6 when I'm evaluating this function at 1. Oh, then I know what a is. A has to be negative 3. If I know what a is, I can put it back here and find out what b is. So I have 2 multiplied by negative 3 plus b has to equal 3. So 2 times 3 is negative 6, which is added to the other side gives me positive 9, so we know that b is equal to 9. Now that we know what b and a is, we can put it back in here. So, actually c. So we have a, which is negative 3, multiplied by x squared, plus b, which is 9. 9, put it in blue, x, plus c has to equal 5. Now this is f of x, but because f of x has to equal 5 when we have 1, then really what we have is we have negative 3 multiplied by 1 squared, 9 multiplied by 1, and this is going to give me my c value. So I have negative 3 plus 9, which is 6, plus c, subtracting 6 from both sides. C has to be negative 1, so here's my function. F of x has to be equal to my a, which is negative 3x squared, plus my b, which is 9x, plus my c, which is negative 1, and there it is. And I did that by going through the process of here is what a quadratic should look like, ax squared plus bx plus c. And I know that when I evaluate it at 1, it has to be 5. The first derivative is going to be 2ax plus b, and when I evaluate it at 1, it has to be 3. My second derivative is 2a. When I evaluate it at 1, it gives me negative 6. So I knew what a was from the third derivative. I can find b from the third and the value that's given to me on the first derivative, and then I can find my function by just doing back substitution. Okay. Let's take a look at our last problem over here now. Let's move all of this out of the way. The last problem is asking me to move this out of the way. Let me move that out of the way. Let me move this out of the way. Let me move this out of the way. Move it out of the way. Okay. This last problem is asking me to find the tangent line is horizontal. So in other words, they're asking me to find the derivative and set it equal to 0. What's the difference between the tangent line being horizontal and the tangent line with a slope of negative 1? You either set it to 0 and solve, or in this case, you set it to negative 1 and solve. So the first thing I'm going to do is find the derivative, which is 3x squared plus 2x plus 1. So I have 3x squared plus 2x plus 1, or excuse me, that should be minus 1. Minus 1 because it's a negative x to begin with, so minus 1. Is set equal to 0. So this factors into 3x and x. I'm going to have a positive 1 here, a negative 1 here. So x is equal, and this equals 0. So x is equal to 1/3, or x is equal to negative 1. These are the two locations in which I have turning points. And like I said before, it's either a maxima or a minima or horizontal slide. I don't know until either I plug them back into the original function or I learn a little bit more later in this chapter. Last problem. I know this is a long video, longer than usual. We're going to set our derivative, which is 3x squared plus 2x minus 1 equal to that negative 1. So we have 3x squared plus 2x is equal to 0, because I added 1 to both sides. Factoring out an x, my answers are at x equals 0 and when x is equal to a negative 2/3. These are the locations in which my slope is negative. It's a negative slope. And we're going to talk about how that negative slope is going to help us determine what's going on with these horizontal slides or turning points. And that's it for this video. Thanks for hanging out. It's a little longer than our usual videos, but There's a lot going on. Make sure you took really good notes and you have a note card with all the rules and start practicing these. And we'll see you in class.